Hello! Welcome to Squid Essays. Inking your academic pen. My name is Julie and I will be your instructor as we read through concurrent engineering definition. The article source is embedded in the video description below. Feel free to read along. Please note that you can get a custom, plagiarism-free essay for as little as $10 a page at Squid Essays. The link is in the description. Concurrent engineering is a manufacturing planning technique that accounts for the manufacturability of a product over the desire to produce the specified product. This includes consideration of the production processes, quality assurances, and the cost and time implications of the production of the product. Benefits to the consumer are improvements to the quality of the produce and affordability in the price, and the benefits to the producer are more efficient and economical work process. 1. This form of engineering defines a methodology applied to the product during the preliminary design phase, considering every part of the product's life cycle, from creation down to disassembly when the product becomes obsolete. Taking into account new technologies designed to aid the industry, computer-aided design and manufacture, production lines, improved communication technologies via internet connectivity. Also, reforms to the working environment can improve the efficiency of the product, team-based working, intermittent quality control. By careful prior consideration to all these points when designing the process for production, a more efficient and economical product can be produced. Examples of concurrent engineering techniques are demonstrated by the launch of the Discovery, made by Land Rover in 1989. From conception to finished product only took 18 months. A massive reduction on the 48 to 63 months that was the normal at the time for products of the same type. This led to the Discovery becoming a market leader and top seller in its class. In an ever more competitive open market, it is becoming more and more important to get the product the consumer wants into the marketplace as soon as possible. Getting it out there before a competitor can lead to big financial rewards and possible future loyal customers. 2. Definition of human factors and human factors engineering. The general term for human factors, HF, is ergonomics. On the other hand, human factor engineering, HFE, can be simplified as an interaction between the humans and the technology. 3. The focus of human factors is human beings and how different designs influence people. The main focus is the things people use and the environment which these things are being used, and change them in order to maximize the capabilities and minimize the limitations of people. The second is to create more comfortable and safer environment and improve the quality of life. They try to comply with the needs of people in order to increase the productivity and decreasing the errors. 4. Steps of application. Step 1. Determine objectives and performance specifications. Define what the system needs to perform. Recognize the operators and any other processes that are connected. Step 2. Definition of the system. Function of the system. Step 3. Basic design. Human factors are distribution of roles to humans, software and hardware, the requirements of human implementation, studying of the function carried out, and finally the task outline. These tasks are carried out throughout as the design progresses. Step 4. Interface design. This step is to ensure that all the designers and engineers work and consider the system development. Human factor experts focus on the human consideration side, while engineers work with the machinery aspect. Step 5. Facilitator design. The aim of this step is to endorse suitable materials for human performance which can influence the previous step. Step 6. Testing and evaluation. During this step, it is essential to test from audio or optical signals whether the products are up to a standard for human implementation. Advantages: reducing errors. People always make mistakes due to their carelessness or negligence, but usually errors occurs due to defect or faulty of the system. Hence, in order to reduce the error, with the incorporation of the human factors criteria, the error can be determined and further analysis can be done in order to design a safer and better system. Reduce liability and the risk of product recalls. Product recalls usually because of the error due to the bad design of the product itself. Therefore, by enhancing the product quality and safety will reduce the risk or product recall and legal liabilities. Reduce product development cost. Making sure what the objectives of a task is the main point of the finance. Leading the users towards the right path of their choice is the simplest and inexpensive way to find out about one's requirement. With these, the number of pending projects will be reduced exponentially and thus, reduce the cost needed for the development. Shorten the market time, understand the time constraint and not wasting it because this will not only affect the time consumption but also money. Organize and plan the work in the beginning in order to suppress the delays. If the task is done before the deadline, the company is able to make more profit margins. Reduce training and support costs. Redesign the system depending on the usability of the system and lessen the value of help desks so that the percentage of training needed is decreased. Reduce product maintenance costs. The price of a system defects, especially once it is released, will surely be at peak. Therefore, it is much cheaper to fix a design during the early stages. Keep it constantly under care in order to prevent any major damage in the future so that less money is needed. Improve customer value. If the users are satisfied with the product, they will sure purchase it and having trust with it whenever they are using it. An average improvement of the productivity will create a usable product which will outweigh the costs. 5. Disadvantage the designers lack in having to put into effect the human factor approach and data. Value to the industry military, Minprint. It is to ensure that the operation goes smoothly while taking the human factors qualitative and quantitative aspect into considerations for the system. These properties required are to ensure that the equipment is easier to operate, maintain and support, reducing the time to finish, decrease the operator training and lowering the number or operator error and accident. 6. Medical. Reducing the medical errors which are caused by the faulty of the system, where it can be divided into 3 sections which are providing unambiguous and timely feedback, minimize distractions, and support error detection and recovery. 7. Reference. A9AYTZ2XZ3, Concurrent Engineering, Concept, Implementation and Practice, Chapman and Hall, 1994. Hamid Parsi and William G. Sullivan, Concurrent Engineering, Contemporary Issues and Modern Design Tools, Chapman and Hall, 1993. McCormick E., 1970. Human Factors Engineering. 3rd ed. McGraw-Hill Book Company. Sanders M., 2002. Human Factors in Engineering and Design. 7th ed. McGraw-Hill Human Factors. Maryland, 2008. Benefits of Human Factors. Online available at http://www.humanfactorsm.com/ handmedicine_benefits.html. Accessed November 17, 2009. U.S. Army Minprint Program 2007. Human Factors Engineering, HFE. Online available at http://www.minprint.army.mil/ minprint/ hfe.html. Accessed November 16, 2009. Human Factors. Maryland, 2008. Reducing Error Through Design. Online available at http://www.humanfactorsm.com/ handmedicine_register_design.html. Accessed November 17, 2009. Thank you for taking your time to listen to me. I hope you enjoyed learning about concurrent engineering definition as much as I did. Kindly remember that you can get a custom, plagiarism-free essay at Squid Essays for as little as $10. The link is in the description. See you next time.